The James Webb Space Telescope, JWST, has sent back a message that has amazed NASA scientists in the vastness of space, where the unknown is infinite. This was more than just another image of a new star or a distant galaxy. It was something that no one could have anticipated. For a really long time, the JWST has been our window into the obscure, uncovering insider facts concealed profound inside the universe. But now it has captured something so amazing that it has shaken our understanding to the core. What might that be? A sign of life? An extraterrestrial shuttle? The universe of science and cosmology is humming with questions, and the responses could change all that we are familiar our spot in the universe. Go along with us as we dive into the disturbing new previews sent back by the James Webb Space Telescope. Pictures that could revamp the historical backdrop of the actual universe. NASA's most powerful and advanced optical instrument, the James Webb Space Telescope, was launched with the hope of discovering the universe's deepest secrets. It has tirelessly observed various nooks and crannies of our vast cosmos ever since it was deployed, revealing mysteries that we have long pondered. Be that as it may, the most recent picture it sent back is not normal for anything seen previously, sending swells across mainstream researchers. Might this frightening disclosure at any point be the way to grasping the universe's most significant puzzles? What exactly has the JWST's gaze captured? This earth-shattering telescope, sent off from the European spaceport in French Guiana, has been set at a vantage point in space that permits it to see further and more profound into the universe than at any other time. Outfitted with cutting-edge infrared innovation and a huge 18-portion reflector, the JWST has outmatched every one of its ancestors, including the incredible Hubble Space Telescope. It is able to see the universe in the infrared spectrum, which enables it to see celestial phenomena that have been hidden from view for billions of years through cosmic dust. Scientists eagerly awaited the JWST's first scientific snapshots as it began its mission. They were absolutely stunning when they got there. The well-known pillars of creation, which can be found in the Eagle Nebula about 7,000 light-years away from Earth, was one of the JWST's primary goals. The Hubble Space Telescope captured these enormous columns of gas and dust for the first time in 1995. They are referred to as stellar nurseries, where new stars are born. The JWST's strong instruments caught these support points in uncommon detail, uncovering complex designs and beforehand concealed stars, some of which shaped only a couple a long time back. This picture alone denoted a huge logical accomplishment, giving new bits of knowledge into the cycles of star development and the development of the universe. Yet, the JWST didn't stop there. It directed its concentration toward other mysterious districts of room, including the Pandora Group, previously known as Able 2744. This district, anticipated by Albert Einstein's hypothesis of general relativity, is a universe group that lies 3.5 billion light-years away. The JWST's perceptions of Pandora's bunch uncovered a staggering all-encompassing picture containing around 50,000 infrared light sources, offering a fantastic perspective on enormous development. The picture caught by the JWST presents an amicable mix of profundity and broadness, showing subtleties of far-off cosmic systems and the huge scope design of the universe that were beforehand obscure. A prominent Milky Way star in the foreground of this image displays an extraordinary diffraction pattern, demonstrating the JWST's exceptional optical capabilities. The distant galaxies of the Pandora's cluster that surround this star shine with a brilliance that has never been seen before. Astronomers have been able to study the intricate web of galaxies and their interactions thanks to the JWST's ability to combine multiple observations into a single coherent image, which has shed new light on the vast structure of the universe. Even more intricate phenomena surfaced as scientists continued to examine the JWST data. One such disclosure was a progression of concentric rings around a far-off star, WR140. These rings, which show up practically rectangular in shape, resist conventional clarifications and have started extraordinary discussion inside established researchers. The image, which was shared on social media by a citizen scientist, quickly went viral, which sparked speculation regarding its origins. Might these rings at some point be proof of an extraterrestrial construction? Or would they say they are basically a characteristic peculiarity that we presently can't seem to get it? These findings have perplexed experts like Mark McCaffrian, a member of the JWST Science Working Group and a science advisor to the European Space Agency. McCaffrey noticed that while certain parts of the picture could be credited to optical diffraction, the red groups found in the rings are for sure genuine, addressing a progression of shells around WR140. However, scientists must ponder the significance of these shells because their precise nature remains a mystery. The scientific community is eager to learn the truth about this mysterious discovery as NASA prepares to provide a more in-depth explanation. The JWST has likewise given new bits of knowledge into the early universe, uncovering systems that challenge our ongoing comprehension of inestimable advancement. Among the most astounding disclosures are antiquated universes with masses that adversary or even surpass that of the Smooth Way. These gigantic worlds, found when the universe was just 3% of its ongoing age, bring up central issues about how cosmic systems might have shaped and developed so rapidly after the huge explosion. These findings, which suggest that galaxies as large as our own existed in the early universe much earlier than previously thought, have astonished scientists like Evolab. The red spots in the JWST snapshots must first be confirmed to be galaxies and not something else entirely before cosmologists can begin to adjust their models to account for these massive galaxies. Our understanding of the history of the universe may need to be fundamentally rethought if it turns out to be true that these galaxies once existed. On the other hand, these red spots might address another kind of cosmic item, one that presently can't seem to be completely perceived. This disclosure has sent shockwaves through established researchers, as it powers specialists to reevaluate the central cycles that oversee universe development and advancement. The JWST's commitments to how we might interpret the universe stretch out a long ways past the investigation of far-off worlds. The telescope has additionally caught stunning pictures of the apparition world, otherwise called NGC 628 or M74. This twisting universe, frequently called the Wonderful Winding because of its balanced shape, has been imaged by a few telescopes, including Hubble and Spitzer. However, the ghost galaxy's dust lanes and the intermediate mass black hole that is thought to be at its center have been revealed by the JWST's infrared capabilities. These perceptions give new bits of knowledge into the design and elements of twisting cosmic systems, offering hints about the cycles that shape them. Exoplanets and their atmospheres have also been studied extensively thanks to the JWST. Its infrared instruments are obviously appropriate for identifying and investigating the compound piece of exoplanetary environments, giving important data about their possible tenability. As of now, the JWST has found a few exoplanets, uncovering insights concerning their temperature, air synthesis, and, surprisingly, the presence of water fume. The first glimpse into the conditions that exist on distant worlds is provided by these findings, which mark a significant advancement in the search for life elsewhere than Earth. The JWST has discovered new information about planets like Uranus and Neptune, as well as smaller bodies like comets and asteroids, in addition to its groundbreaking work on exoplanets. Its perceptions of Uranus, for instance, have revealed insight into the planet's environmental structure and atmospheric conditions, offering new experiences into the elements of ice monsters. The telescope's capacity to concentrate on far-off comets and space rocks has additionally given important data about the early planetary group's circumstances, assisting researchers with sorting out the historical backdrop of these little heavenly bodies. The JWST's perceptions have additionally progressed how we might interpret dim matter and dull energy, two of the most secretive parts of the universe. By catching definite pictures of cosmic system groups and huge scope structures, the JWST has given information that could end up being useful to researchers derive the properties of dull matter and dim energy. These perceptions are basic for understanding how these concealed powers impact the construction and development of the universe. The JWST's profound field pictures, which include noticing a little fix of sky for broadened periods, have uncovered weak and far-off objects that offer a window into the early universe, giving new insights about the development of the main worlds and inestimable designs. The JWST's ability to investigate cosmic dust in incredible depth is one of its most remarkable achievements. Understanding the properties of cosmic dust is essential for comprehending various astrophysical processes because it plays a crucial role in the formation of stars and planets. The JWST's high-goal perceptions of residue have given new bits of knowledge into its structure and dissemination, revealing insight into what it means for the development of heavenly articles. The JWST addresses a huge jump forward in mechanical capacities contrasted with its ancestors. It can gather more light and produce images with a higher resolution than any other telescope thanks to its large segmented mirror. Its high-level instruments, including the close-to-infrared camera, NIRCam, and the mid-infrared instrument, MIRI, cooperate to cover a great many frequencies, giving a far-reaching perspective on the universe. In addition to observing, the telescope's goal is to provide answers to some of astronomy's most fundamental questions, such as how galaxies, stars, and planetary systems began. By concentrating on the universe in its outset, the JWST expects to give replies to inquiries concerning how the primary stars and systems shaped and how they developed into the designs we see today. Its initial perceptions have previously prompted pivotal revelations that challenge existing speculations and push the limits of our comprehension.